Alright, so again, all you gotta do is follow the pattern. Once you get the pattern, makes total sense, you can write this pattern on your note card. Alright, if you have two values, a binomial, and they're both perfect cubes, that's what has to be. They have to be perfect cubes. If they're not perfect cubes, you can't do it like this. Just like with the sum and difference of squares, they had to be perfect squares. Okay? The difference is with cubes, it works whether it's a positive or a negative. Alright, so I have a to the third power, b to the third power. Here's how it factors. You take the cube root of each of them and put it as the first binomial. Cube root of a cubed is a. Cube root of b to the third is just b. With me so far? Then you take the a, the first term, you square it and put it here. Take the b, which is the second term, square it and put it at the end. And then you multiply the two things together and stick it in the middle. Don't worry at all about the plus and minus signs yet. Then for the signs, you look at the original sign and you put it down here like this. Same sign, opposite sign, and then the last one's always positive. Same, opposite, positive. What's up? You see this thing with no signs, you're like, hey baby, what's your sign? Sup. What's up? So you got that, Ed? Same, opposite, positive. Sup. It's the equivalent of how you doing. Alright, watch. We can do this. Adam. A to the third, so what goes here? Oh. And the first one, it's just all the way down. A. Yeah? What goes here? Just B. The first one's the small one, right? Just A, just B. Now you take the two and square them. A squared here. B squared here. What goes in the middle? AB. And then for the signs, Tim, you say, what's up? Same sign, opposite sign, always positive. And it's factored. But of course, it's not always just going to be like simple A and B. We get a little more complex. All you have to do is check and say to yourself, hey, is that a perfect cube? Okay? The letters are perfect cubes if the power is divisible by 3. Is 3 divisible by 3? Sure. Is 6 divisible by 3? Sure. So those are both perfect cubes. Is 8 a perfect cube? What's 2 times 2 times 2? It is 8. Brainod, is 27 a perfect cube? What is it? What times what times what is 27? 3, right? Alright, so they're both perfect cubes. We can totally factor this. First, we take the cube root of 8a to the third. That's 2a. Bear with me so far? We just take the cube root of that. The cube root of 8 is 2. The cube root of a to the third is just plain a. The other term, we take the cube root of that. What's the cube root of 27? 3. What's the cube root of b to the 6th? Here, look like this. We're taking the cube root, right? That means 3 guys got to come out. So b to the 6th is v squared times b squared times b squared. Everybody agree with that? So the cube root of b to the 6th is they get to come out as 1b to the 2nd. Cube root is the same as dividing the exponent by 3. Alright, that's what we did with the a's, divided by 3. Divide by 3. Okay? Now we take this term and we square it and stick it here. What's 2 squared? 4. What's a squared? A squared. Good. We take this one, square it, and stick it at the end. 3 squared? 9. B squared squared? B to the 4th. And then the middle term, you just multiply them together. What's 2 times 3? 6. And then you get the AB squared. Lastly, Tim, what's up? Same, opposite, positive. Done. Isn't that fun? You love it. Questions on that? It's just a pattern. Just follow the pattern. Write the pattern